Hello, scholars. Again, I hope all is well with you. This is lesson number 2 in our pre-skills unit. Again, we are going through skills and concepts that will prepare you for the work that we will be doing throughout this school year. This second lesson focuses on computation involving whole numbers. Now, keep in mind, everything in these 7 lessons of the pre-skills unit is done from the premise that you will not be using a calculator. Yes, you do need to know how to do computation and work without a calculator, especially as you all start to prepare for some of the college placement tests that you will have, i.e. the SAT, since there is a no calculator component on the SAT. With that being said, let's go over a few things before we dive into whole numbers. So remember, when you're adding, you're looking for the sum. Subtraction is difference. Multiplication is product. And division is quotient. So if you don't see the word adding, but you see sum, just know that you're still being asked to add. So today we're going to look at whole number computation, how to add, subtract, multiply, and divide whole numbers, along with working at word problems that go with these whole numbers. Word problems are a part of the mathematics that we will be learning. Word problems will show up throughout our time in our math class, so it is the expectation that you will work with word problems. But we're going to start with the computation. So we have adding, subtracting, multiplying, and dividing. So we'll literally go straight through the list. We'll literally go straight through the list, and we're going to start with adding. So adding, of course, we add place by place, carrying numbers as necessary. So 29 plus 58. Now, I always set up my adding the elementary school way, setting up and down. So 29 plus 58. 9 plus 8 is 17. Bring down the 7, carry the 1. 1 plus 2 is 3. 3 plus 5 is 8. So you end up with 87. So again, if you're solving it without a calculator, I set it up the elementary school way and I keep it moving. Same thing with example 2. 258 plus 612. So again, set it up the elementary school way. When you solve it, you start from the back and you work your way to the left. So 8 plus 2 is 10. Bring down the 0, carry the 1. 1 plus 5 is 6, plus 1 is 7. 2 plus 6 is 8. So 870 is your final answer. So adding, simply set it up, solve it out. Move to subtraction. So subtraction, we subtract place by place. Remember, we borrow as needed. So 89 minus 52, 89 minus 52. Starting from the right, we have 9 minus 2, which is 7. 8 minus 5, which is 3. So leaves you with 37. Another example, 675 minus 192. So 675 minus 192. Again, if we start from the right, 5 minus 2 gives you 3. Now, I can't take 9 from 7, so now I have to borrow. So make the 6 a 5, and change the 7 to a 17. 17 minus 9 is 8, and 5 minus 1 is 4. So you're left with 483. So sometimes you will have to borrow, sometimes you won't. It just depends on the problem that you're working with. Multiplication. So with multiplication, we multiply one place at a time, putting in placeholders as we need to. So 37 times 8, 37 times 8. Again, start from the right, work your way over. 7 times 8 is 56, so bring down the 6, carry the 5. 8 times 3 is 24, and then 24 plus 5 gives you 29. So you wind up with 296. Do another example of multiplying. 49 times 13. So since they're both two-digit numbers, it doesn't really matter which one goes on top. So 9 times 3 is 27. Bring down the 7, carry the 2. 3 times 4 is 12. Plus 2, 14. So now we're moving from the 3 to the 1. So the 3 requires us to put a placeholder. So we bring down a 0. And now we go over to the 1. 1 times 9 is 9. 1 times 4 is 4. We're done multiplying with the 1. So the 2 rows of numbers that we have, we add them up. 7 plus 0 is 7. 4 plus 9, 13. 1 plus 1, 2. Plus 4, 6. Leaves us with 637. So far we've done adding, subtracting, multiplying of whole numbers. So now let's move to division. So when we division is a particular way that we have to set up the problem. So the first number is known as your dividend. The dividend always goes inside of our division box. The second number is the divisor that goes outside. So it's always set up in that fashion. So now we start dividing. So we have an 8 sitting outside, we start with the 4. We ask ourselves, how many times will 8 divide into 4? It doesn't. So I'll put a 0 up there to let myself know that I've tried that and it didn't work. Now we move on. 8 divides into 47 5 times. So we want to figure out how many times can it divide without going over. 8 times 5 gives me 40. 8 times 6 would give me 48, and that's too much. So 5 times 8 is 40. We're going to get rid of this line underneath here, just to avoid a little confusion. 5 times 8 is 40. 47 minus 40 is 7. Bring down the 2, and we keep dividing. 8 goes into 72 9 times. So 9 times 8 is 72. And we subtract. That's 0, and that's 0. 72 minus 72, 0. So your final answer ends up being 59. So your final answer is 59. You do not need the 0 sitting in front. That's simply as a placeholder more than anything else. So, of course, you can always have remainders like we will with example number 2. With the second example. So 3250 divided by 20. 3250 divided by 20. So now let's go ahead and check those out. Again, 3250 goes inside, 20 goes out. So 20 does not divide into 3, so we'll put a 0 on top of 3. 20 does divide into 32 once. 1 times 20 is 20. 2 minus 0 is 2. 3 minus 2 is 1. Bring down the 5. 20 divides into 125 6 times. 6 times 20 is 120. So if we subtract, that leaves us with 5. Bring down the 0. So 20 goes into 50 twice. 2 times 20 is 40. 50 minus 40 is 10. So we don't have any more numbers to bring down, so we've finished our division. So this ends up becoming 162 remainder 10. Now, of course, this is not the only way that you can write your answer. You can also write it as 162 and 10 over 20. Which if you are writing it as a fraction, you would have to reduce the fraction. So this would become 162 and 1/2. Now, of course, there are some of you who remember from middle school that if you didn't finish, then you would put up the decimal and then bring down another 0. 20 goes into 100 5 times. 5 times 20 is 100, which would give you 0. So that means your other answer could be 162.5. So once remainders get involved, there are several ways to write your answer. So just noted, once remainders are involved, fractions and decimals can come into play too. So that takes us through adding, subtracting, multiplying, and dividing in its basic format. There are a couple of shortcuts that do exist if you are multiplying or dividing by a power of 10. So a power of 10 would be 10, 100, 1,000, 10,000, etc. Now this only works if you are multiplying or dividing by a power of 10. So keep that in mind as we do this. So, example 9, you have 273 times 100. You can always set it up the long way and solve it like that. If you solve it that way, that will get you to the right answer as long as you do your computation correctly. However, since you are multiplying by 100, there's an easier way to solve it out. So here's the shortcut. First, you would just take 273 and multiply it times the 1. So we're going to put the shortcut here. So 273 times the 1, that's easy, that's just 273. So we dealt with everything except these 2 zeros. So for those 2 zeros, you put those 2 zeros at the end of the problem. So put the zeros at the end. So your answer would be 273 with 2 zeros attached to it. 27,300. 27,300. So, as I mentioned, you do not have to do it that way. You can always do it the long way. You will still get the same answer. You will still get the same answer. So don't feel that you have to do it the shortcut. So notice that with multiplying, we put zeros at the end. With division, we're going to take zeros off. Problem 10. So again, problem 10, you can still do it the long way. 52,800 inside, 10 on the outside. You can divide it the long way, no problem. Or you can do it using the shortcut. So for the shortcut, we're going to take 52, 5,280, take the whole number divided by 1. So 52,800 divided by 1 gives you 52,800. So nothing changes. So this time, instead of putting zeros at the end, we're going to take zeros off of the number. Take zeros off of the answer. So notice that we have 1 0 left. We have a 0 at the end. So we're going to take that 1 0 off. So your answer is 5,280. Answer is 5,280. So again, remember, it's a shortcut. You don't have to do the shortcut. Now, when you're not using a calculator, shortcuts come in handy. But just know that you are not required to do the shortcut. But that only applies with adding and with multiplying and dividing. Adding and subtracting, there's no shortcuts for that. You have to know how to set it up and do it the long way. All right, so we're going to finish off whole numbers by looking at word problems. Again, word problems are going to happen. The main thing with a word problem is that you have to read it. Read it, interpret the information that is given to you, and then start solving it out. So example 11. What is the area of a rectangle that is 4 feet long and 18 feet wide? Remember, the area of a rectangle is found by taking the length times the width. First thing you do with every word problem is to read it. Gather information. So you have a rectangle that is 4 feet long, 18 feet wide. Of course, this is not drawn to scale. They're telling you that the area is length times width. So that means we're looking for what is 4 times 18. So that's what they want us to solve for. So now that we know what we're supposed to do, let's go ahead and do it. 18 times 4, 8 times 4 is 32. 4 times 1 is 4, plus 3 is 7. So you have 72 square feet. 72 square feet. So again, primary thing is make sure that that multiplication is correct. You'll probably get by, depending on the class that you're in, with the multiplication. As long as you have the number correct, you'll probably get by with not having the units. Problem 12. If Danny cut 34 centimeters from a piece of wood 130 centimeters long, how long was the piece that was left? So you have a piece of wood that's 130 centimeters long, and you're cutting a piece that's 34 centimeters. You want to know how much is left. All right, fair enough. So that's 130 minus 34. 130 minus 34. So we go ahead and we set it up. So 4 doesn't divide into 0. So we borrow off of the 3. 10 minus 4 is 6. So now we have 3. Can't take 3 from 2. Make the 1 a 0. Make the 2 a 12. 12 minus 3 is 9. So 96 centimeters. Yeah, not a hard problem, just one that requires you to read the problem, interpret the problem, and then solve the problem. Read it, interpret it, and then solve it. Last 2 examples here. James sold 128 tickets this week and 87 tickets last week. What was the total number of tickets she sold? So a keyword for adding is total. Just like a keyword for subtraction is left. How much was left? So total here simply is telling us to take 128 plus 87. Then we do our computation. 8 plus 7, 15. 1 plus 2 is 3, plus 8 is 11. 1 plus 1, 2. So 215 tickets. 215 tickets. Finally, example 14. On their vacation, the Smith family drove 864 miles in 12 days. If they drove the same number of miles each day, how many miles did they drive each day? Key thing here, they drove the same number of miles each day. So they took over each of the 12 days, they drove the same amount, and then they stopped. So this is a clear division problem. So 864, total number of miles divided by 12 days. To figure out how much they did total. So 864 divided by 12. 864 goes inside, 12 goes out. 12 doesn't go into 8, but 12 goes into 86 7 times. So 7 times 12 is 84. 86 minus 84 is 2. 12 goes into 24 2 times. 2 times 12 is 24. And then 24 minus 24 is 0. So you're looking at 72 miles per day. 72 miles per day. Again, the main thing you're looking for is making sure that the computation is correct. You might be able to get by with not having the units, but the computation needs to be on point. So again, we did an example, adding, subtracting, multiplying, and dividing the word problem. Word problems are going to happen, so just get used to it. The better you practice with word problems, the better off you'll be. With that being said, that completes this video with reviewing whole numbers. Next time we'll look at decimals, adding, subtracting, multiplying, dividing, along with doing word problems associated with it. Again, feel free to use this recording as much as you need to refresh and remind yourself, as well as the notes which will be uploaded to Google Classroom. Take care and have a good one.